Hi, today we are going to look into the properties of ammonia. The two properties that stand out among the physical is it is lighter than air. First property among the physical properties is ammonia is lighter than air. This we see even when we were collecting it, it was collected by downward displacement of air because air is heavier and ammonia is lighter. The second property that we see is it is highly soluble in water. And to prove this high solubility in water, we use the experiment called fountain experiment. The round bottom flask that is inverted is filled with dry ammonia gas, and there is the trough that contains red litmus solution, and when the dropper containing water is squeezed, it releases this water and comes in a contact with ammonia, and it forms some ammonium hydroxide solution here. Because of this, a partial vacuum is created inside the flask. And due to this partial vacuum, now here the pressure increases and it makes this red litmus solution gush into the capillary tube with such force that it emerges out as a blue fountain. So the red litmus solution becomes a blue fountain. Now the conclusions for this is that ammonia is highly soluble in water. And besides this, we could also say that because ammonia is turning this red litmus into blue, ammonia is basic in nature. So these are the conclusions of the fountain experiment, basically to prove that it's highly soluble in water. Now we move on to the chemical properties of ammonia, and the first one is combustibility. Ammonia is non-combustible, which means it does not burn and it does not support combustion. So it's a non-supporter of combustion. There are some children in the class who will be quiet, who will not react, who will not interact as long as they are alone. But when somebody else comes in, they are very interactive, they start talking. Similarly, when ammonia is burnt in oxygen, then it starts reacting. So the first thing that we see here is burning of ammonia in oxygen. For this, there is a simple experiment where we take a glass jar like this with two tubes inserted, and we plug some cotton wool here. And then try to ignite this part, passing only ammonia gas into it and we try to ignite, it doesn't burn. Just like the lone person, it doesn't react. No reaction happens. But when oxygen is also passed and then when it is ignited, it burns with a greenish yellow flame. It's something like this. Now, this reaction actually, ammonia reacts with oxygen to give nitrogen plus water vapor. This is the reaction that's happening here, and this is how ammonia burns in oxygen. So there is the equation and the observation. These two are important. Next we move on to the catalytic oxidation of ammonia. Here again, it does not oxidize by itself, but it needs a catalyst and a lot of heat. We take a combustion tube, which is a hard glass tube, which can withstand very high temperatures, and through this is connected to another tube through which both the gases, ammonia and oxygen, are let in. This is the catalyst. That is platinum. And it's heated. Now when it is heated, reaction begins. And the reaction, the heat that is needed here is 800 degrees Celsius, which is very high. The moment the heat gradually increases, ammonia reacts with oxygen in the presence of platinum and at 800 degrees to give nitric oxide and water vapor. And 5 oxygen. So this is the reaction that happens, and it is a highly exothermic reaction. What is the meaning of exothermic? Is whenever heat is liberated or given out, exit, therm, heat is just given out, then it is called exothermic reaction. So a lot of heat is evolved. Therefore, initial heating is enough. Once the reaction begins, the reaction itself gives out heat, so the heat is removed. Now, when nitric oxide and water vapor are given out, water will condense on these sides, whereas this nitric oxide reacts further with more oxygen and it forms reddish brown fumes of nitrogen dioxide, which means there is further reaction happening. So here you can see some reddish brown fumes. Okay. Even after the heat is removed, the platinum is still glowing. Now, how do you get this reddish brown fumes? Nitric oxide has reacted further with oxygen. Remember, the oxygen supply is still there to give reddish brown nitrogen dioxide. So, there are two reactions that we need to remember. The first thing, forming nitric oxide and water vapor, highly exothermic and catalyzed. The second reaction, it continues to form reddish brown nitrogen dioxide. Two equations and two observations. The observations that we need to make a note of is the platinum continues to glow. That is the first observation. And the second one is there are reddish brown fumes of nitrogen dioxide. So this is what we learned in catalytic oxidation of ammonia.